This second type of triangle here is our overlapping triangles, but they do look different because these are not right triangles with an altitude giving me 3 right triangles. This is just giving me 2 triangles. And the key here is once again being able to draw our triangles out separate. So I'm going to go ahead and do that. I have the luxury of being able to just physically pull them out like this. What you should see is when I pull that big triangle out, I get 6 and 8. Well, this isn't a side length of 68. That's a segment addition problem. So it's not 6 and 8. It's 6 plus 8, which is going to give me a side length of 14. Similarly, I have a 9 and a y. Well, this isn't a 9 and a y. It's a segment addition problem. It's 9 plus y. When I rewrite the second triangle, trying not to get the n in there, there we go. I come down here. I have all 3 of my side lengths labeled. I have D, W, and E. I should see, here's one congruent angle. What's my second? Ah, that's right, just like before. This angle is the same angle here and here. That's the reflexive property with angles. So when I am writing a similarity statement, I have been given that angle P is congruent to angle D. And since I drew them out separate, I will allow you to write that. If you don't draw them out separate, you would have to not say angle D, but angle EDW or angle WDE. And angle E is congruent to angle E. We do have to defend Y by the reflexive property. Therefore, my triangles are similar. Triangle PEN is similar to triangle DEW. Make sure your angles, your corresponding congruent angles, match up. P and D, E and E, N and W, by angle-angle similarity. Just like before, now I have my corresponding sides. Then I want to find, I have X that I'm solving for, so I need to solve for this side. Well, PN corresponds to DW, so there's one ratio, X over 10 equals, well, the 9 plus Y won't help me, so I'm going to go to this side length, which I know is 14. NE. NE corresponds to WE, that's this side length here, so I can state that 14 over 8 is my other ratio. The rest is algebra. Cross multiply, 8x equals 140, I divide, and yes, I get a decimal, and that's okay, I get x is 17.5. For my scale factor, you already have a similarity ratio. You have to write this scale factor in the same order that you wrote your similarity statement. Okay, so my similarity ratio would be triangle PEN to triangle DEW, or in this case, 14 to 8. That's my similarity ratio, which when simplified becomes 7 over 4. My scale factor is the reciprocal of that. It is 4 over 7. Along those same lines, I want you guys to try number 4. Go ahead, press pause, and try to do the whole thing. When you're done, unpause to check your work. So in this case, angle V and angle NAG are congruent. Angle I and angle GNA are congruent because they're corresponding angles of parallel sides. So I said that angle GIV, the big triangle, is similar to triangle GNA, the small triangle, by angle-angle similarity. Use that to set up your proportions and solve. After we do that, we get x equals 2. Now to find my scale factor, my similarity ratio, in this case, is going to be 2 plus x over 2. Use one of these. Okay. Well, that's going to give me, since x is 2, 4 over 2 or 2 over 1, so my scale factor is 1/2. If you have those switched, that might be because you did the small triangle is similar to the big triangle, and that's okay. That'll be on me to determine. Your scale factor and similarity ratios have to match up with your similarity statement. If they match, you're okay. The third video today will also be a short video, and it's going to cover what we call railroad track problems, which are just a corollary of these overlapping triangle problems. Go ahead and go to Canvas to look at those.